Hi there, this is Miss Cave, and today we have a lesson on Virginia 8.17, solving multi-step equations. And for multi-step equations, we have two different types that we're going to look at specifically, one of which is variables on the same side, and the other is when we have variables on both sides of the equations. We've been working with models so that we can come up with the steps for solving equations and so that they make sense to us. So today what we're going to do is we're going to get away from the models a little bit and start looking at the procedures that we follow for solving multi-step equations. So let's go ahead to the first problem. So this would be an example of a problem with variables on the same side. So we're not having variables on both sides yet, we just have variables on the same side. When we're solving an equation, the first thing that we're going to do is draw a line. And then we're going to go through and solve step by step, remembering to show our work for every step. So when we learned how to when we learned how to simplify expressions, if you recall, the first step was to change everything to addition. We had the addition, distributive, and combine. Okay? What we're going to do now, you may still choose to do that, but I'm going to show you how to do it without changing everything to addition for some of the problems. So some of them it's not really necessary, so I'm not going to put that A in for every problem. But over here in the summary, I'm going to go through the steps. So for this, our number one is going to be to use the distributive property, because we always want to get rid of any parentheses in the problem first. If you notice up top, there aren't any parentheses, but you will have problems with them. So you're trying to get rid of the parentheses first, if there are any, and there are some on the bottom. So that's going to be our first step. After we change to addition if we want to. That's going to be an optional step for you. If you're being successful without doing that, you don't have to. I did talk with Miss Lewis, your algebra teacher for next year, and she says she teaches them not to. So I do talk with her a good bit to make sure that you guys, it's consistent what I'm doing in this class for what you'll be doing next year in algebra. And I don't want you to be confused. All right, so for number two, after we distribute, what's the next one? What's the C stand for? Combine like terms. So before we can solve an equation, we have to get rid of any parentheses. Actually, that's part of our solving. And then the second step is to combine like terms, and we know what those are. And then the third step is going to be just solve by undoing, right? We're undoing, and I'm putting that in parentheses because I don't think that's a real word, undoing operations. So that means if we have addition, we're going to subtract. If we have subtraction, we're going to have addition. And then the other two that go together are multiplication and division. All right, so the first equation there, I'm going to look at the first step. It says use the distributive property. Are there any parentheses in the first one? No, there aren't, so I'm going to go on to the second step, which is to combine like terms. So for combining like terms, to make it clear, I'm going to put a box around the terms that are alike. Those are our like terms, because they both have an x, and just x to the power of 1. Okay? I'm going to combine 3x and 2x, and when I combine 3x and 2x, what do I get? 5x. So I'm going to combine them. The commutative property allows me to change the order. We've talked about that in class. And then that's going to be equal to 36. So that's our first step. All right, and now we have a two-step equation. So we're going to undo the subtraction. Again, we're trying to get the variable by itself, so we can put a box around the variable. We're trying to get x by itself. So we're going to add 4 to both sides. We're going to undo the subtraction by adding 4 to both sides. The negative 4 and positive 4 cancel out. I have 5x. Again, I'm trying to solve for x. That's why I'm putting a box around it, is equal to 40. So when I have a number next to a variable, what operation is that? Multiplication. How do I undo multiplication? Division. So I'm going to divide both sides by what? 5. Whatever number is next to the variable, that's what we're going to divide by. 5 divided by 5 is simply 1x, or x. And then 40 divided by 5 is going to give us a solution of 8. Any questions on that first problem? Pretty easy. You're just combining. The only extra step is to combine the like terms. All right. The second one has a little bit more to it. Let's change our color. Let's go with green. So we're going to put our line down here. All right. So what's our first step? Do we have any parentheses? No. So what's our first step? Combine like terms. And you guys can just answer as a class. That's fine. All right. So we're going to combine 12x. So watch what I'm going to do. Instead of changing this to addition, I'm going to just put, I know this is plus and negative, so I'm just going to put a box around the negative 3x. Because if I change it to addition, it would be plus negative 3x. So I'm just going to put a box around the negative so I include that negative with the 3x. So now I'm going to combine 12x and negative 3x, which is 12x minus 3x, and that gives us what? 9x. I'm also going to combine my 9 and my 5, right? Because I can combine the ones. So how many ones would that be? 14. And that's equal to negative 49. I'm going to go ahead and put a box around my x so that I can keep my variable isolated. That's what I'm trying to get alone. And then my next step is to undo the adding 14 by subtracting 14 from both sides. When I do that, the 14s cancel out, the positive and the negative. I bring down my 9x. I still don't have my variable alone. Negative 49 minus 14 is negative what? Negative 63. All right. 9x means multiplication. How do I undo multiplication? Division. I'm going to divide both sides by what number? And then x is equal to negative 7. So how is number 2 different from number 1? Has a negative. Layla? You have whole numbers that you can combine in addition to the variables. So there was an extra step. You had 2 things to combine. We did it in 1 step. All right, let's look at the third one. Now the third one has what? Parentheses. So what am I going to do before I combine like terms? Distribute. So I'm going to distribute. That's my first step. So it's 3x plus 5 times x is 5x. And then 5 times 2 is 10. But it's subtraction, so I have to put the negative in front of it. Now if you change that to plus negative 2, you'll still end up with a negative 10. And then that's going to be equal to 14. Okay, so our first step, not sure where that red came from. I guess our smartboard has the holiday spirit, perhaps. We'll see what happens next. Okay, so this time, next we're going to do, so we did the distributive property. We're going to combine like terms. So we have 3x and 5x. And there's nothing on, oh, I forgot to put my line down. There's nothing we can combine with the negative 10. There's a 14 on the right, but you can't combine across the equal sign. You can only combine when they're on the same side. You could add or subtract from both sides, but you can't just put them together. So 3x plus 5x is what? 8x minus 10 equals 14. I have to put a box around the x, yes. That's the strategy I'm using, putting a box around the x. So I can keep up with that variable. So now I undo subtracting 10 by adding 10 to both sides. There's that red again. I think I hear reindeer. Okay. Yes, yes, yes. Cancel out. I bring down my 8x equals 14 plus 10. 24. Divide both sides by 8. And then x is equal to 3. I'm telling you, these are so much easier because we already know how to simplify. I've never taught simplifying before. I usually teach it with it, and I think this is going to be it's going to go a lot more smoothly since we already know how to do that part. Okay. Any questions on the first 3? All right, so on the bottom, now we have variables on both sides. So we're going to scroll down to the bottom, and we're going to try these 3 problems, and then you guys get a chance to practice in class today. I'm going to give you a partner practice where you get the same answers to the questions. You get to compare. That's what we're going to do today and tomorrow. All right, so for number 4, our first step is to combine our variables on both sides. So what should be my first step? Do I even have anything to combine? No. Okay, our first step is going to be distribute. So we're going to go down to the summary here so that we can keep track of our steps. So our first step is to distribute. And again, that's only if we can. If we don't have any parentheses, we just skip on to the next step. Our second step is just like before, combine like terms. Bless you. Combine like terms. Our third step is to get variables on one side. Okay, so if you have variables on both sides like you do here, you're going to have to figure out how to get them on one side, and there's different ways. So get variables on one side, just like you did with the models. You had to cancel out on one side so that you could keep them on the other. Now the thing about variables on one side, sometimes we're not sure which side to put them on. Here's the secret. It doesn't matter. If you do it on the other side, you'll still get the same answer. But we'll look today which is the easiest side to do. Sometimes you don't want to get it, you want to make everything positive if you can. We try to stay away with negatives if possible. Sometimes that's not possible. But if it's possible to get rid of a negative, we do that. Okay? Not required, it just makes it a little easier. So, looking at the first one, we have, number 4, sorry. The last step is to solve. Just like we do equations. Undo and do. Undo what's done. Okay, so we have negative 2x, look, and I have 4x. Can I combine them? No, I can't combine them because they're not on the same side. So I'm not putting them together. So it's not the same thing as step 2. But I do need to look at step 3, which is to get variables on one side. Right now I have x's on the left and x's on the right. So just like I said before, I'm going to try to get rid of any negatives. So if I want to get rid of the negatives, I'll get rid of the 2x, not the 4x. Okay, I could subtract 4x from both sides, but then I'm going to have a negative on the other. So the easiest way to do this is to add 2x to both sides. So I'm going to add 2x to both sides. All right, when I do that, the x's go away on the left. I still have my 15. I now have 6x plus 39. Okay? So now I just have a regular two-step equation with the variable on the right. And it doesn't matter what side the variable's on. We just need to make sure that we're isolating the x. It's a strange looking x, but I don't know. It's very special. It's kind of like a stick man. He's doing this. Okay, all right, he's spirited. He has the spirit. Okay, all right, so we're going to subtract. Look over here on the right side with the 39. We're going to subtract 39 from both sides. This cancels out. We bring down our 6x. 15 minus 39 is negative what? 24. Okay, we divide both sides again by that variable we're trying to get, or excuse me, by the coefficient. We're going to try to get the variable by itself. So this cancels out. 6 divided by 6 is 1. That's 1x. Negative 24 divided by 6 is what? Negative 4. Yeah, it's not that hard. It's like a puzzle. I love equations. I really do. It's easier than with the pieces. Yeah, but now you know why not to combine, because you can't put 1's and x's together. And now you know why you can't just combine across the equal sign. You can't put x's on the right with on the left because of the rules of the equation. The point of the models is for you guys to see how the models connect to the procedures for solving the problems. So if you forget, you can think back to that picture. You've had that experience of working with the models. Okay, so the next one, we've got a little more going on. Let's change our color. I think the smartboard wants us to use red. Okay, so do we have any distributing to do? No. Can we combine like terms? Yes, yes we can. But you need to keep in mind, I have 13x over here. I have 10x over here. I'm going to put a box around the negative 4x. You see what I did? I put it around the negative sign because I'm subtracting it, which is like adding a negative. But can I put 13, 10, and negative 4 together? No, because they're on different sides. You can only combine when they're on the same side. So on the left side's going to stay the same. It's going to be 13x minus 5. The right side, I'm going to combine 10x and negative 4x, which is going to be 6x plus 37. Okay, see what I did? I could only combine on the right side. All right, now my next, I did my like terms, and now I've got to get variables on one side. So I have 13x over here. And I've got 6x over here. I don't want them on both sides because I need to isolate the variable. I could take 13x from both sides, but what would happen if I took 13x from both sides? I'd have a negative, yuck. If I can avoid the negative, I do. So instead, I'm going to take 6x from both sides. Okay. And then now I have 7x minus 5. This cancels out, and I have 37. And I'm solving for x. I undo my subtraction. I add 5 to both sides. This cancels out. 7x. Oops, oh, that's terrible. It's not me, it's the pen. Equals 42. And then my last step is to do what? Divide by 7, because I'm trying to isolate that x. Divide by 7. And I'm going to squeeze my answer in here. X is equal to 6. All right. Last problem. How's this one different? What do we have? It has a distributive property. And look at all those negatives. Be careful. But I'll show you how you can do it without changing to addition. So we're going to start first with the distributive property. So it's negative 7 times x, which is negative 7x. Okay? Now, look at what I'm multiplying the next part of the distributive property. it's -7 times -1 because there's a negative sign in front of the 1. Do you guys see that? So it's actually going to be -7 times -1, which is what? 7. +7. If you need to change that to plus -1 for it to make sense to you, do that. But I'm showing you a little bit of a shortcut. Layla? I know, because -7 times -1 is +7. Allison? Thank you. Yes, we need that line to keep it straight. Thank you. All right, and then on the other side, it's going to be -5 times x, which is -5x. And then it's -5 times what? -5, which is 25, not 10. We were adding it. Okay? So now, because you're multiplying -5 times, you're subtracting. So if I did the -5 times 5, it would be -25, but you'd be subtracting -25, which is the same thing as adding +25. So think of it like this. It's -5 times -5 because it's plus a -5. That's actually, you're taking away 5. So -5 times -5. Okay. All right. So now we are going to go to combining like terms. Can I combine any like terms?
Yes. No.
No, because they're on what? Different sides. So we're going to skip on to step 3, which gets the variables on the same side. So how could I make that positive? How could I get rid of negatives? Add what? 7 or 5x? If I add 5x, I'm still going to have negative on the other side. Add 7x to both sides. See that? And then I'm going to add 7x. Sorry, I didn't mean to do that. I was just rewriting the equation. Plus 7x over here. Okay? Because what's going to happen is the -7 is going to cancel out. I'm going to bring down my 7. And then I have -5 plus +7x. -5x plus +7x. So that's going to give us 2x plus 25. How did I get the what? -5 times -5. So now my variable is on the right. I subtract 25 from both sides. Right? Did we mess up? Okay. So we get 7 minus 25 is what? -18 equals 2x. We're isolating our variable. We divide by what? 2. And I'm going to have to go into my little space here. I'm sad about that, but it happens. And x is equal to what? -9. -9. Is it okay that I switched my variable to the other side? Yeah, because it's an equation. That's okay. You don't have to. You could say -9 is equal to x. Okay. That's it for our lesson on multi-step equations. Have a great day.
Bye, Desiree.
This was dedicated to Desiree Brown.